Automatic bed tracking system in hospitals using IoT. Abstract. There is a lack of effective tracking system for the bed availability. This work has taken it as a key challenge. To solve this problem, our work uses sensors to detect the availability of patient in the bed. This work also broadcasts it to the web page to all to know the availability of beds using IoT. This theory may limit to short samples and may need more bandwidth for very high samples of bed availability check. This work does not limit only to pandemic, and it can be extended to bed tracking without broadcasting to the web. It can be used to monitoring internally in a hospital administration level. Keywords: IoT Internet of Things. 1.0 Introduction. During pandemic, there was the unavailability of systems to check whether beds were available with the required infrastructure for the affected patient/s. To solve this problem, this work uses the dimensions of the bed as 914 x 2032 mm for this work. This calculation/s can be extended to any hospital bed. This work uses Atmga-based microcontroller to control the sensor signal and send the signals to a web portal. The sensor used in this work is the laser-based sensor. When the laser cuts in between where the patient lies, it compares the calculated velocity of the speed of laser light with the instantaneous velocity of laser light. If the comparison is true, it displays a certain output. When the status is false for a certain time period, this controller prints the value that the bed is available. It works vice versa for the other case. This work may require the right bandwidth to continuously make status available while hosting it using IoT. It can be used to view it internally without hosting it for administration purposes. 2.0 Literature Survey. 2.1 Nath and ETL have proposed in their work titled Designing and Testing a Laser-Based Vibratory Sensor the parameters/s to be tested and checked while using the laser-based sensor. This work also gave insights into the scope of these sensors. These parameters help to determine the boundary conditions of our work for laser. On greater researches, these boundaries could be extended, and the bed tracking system could be amplified. 2.2 Shanhe, Shalungfeng, and ETL have proposed in their work titled IoT-based laser inscribed sensors for detection of sulfate in water bodies for lasers. We used this work for the interface of the sensors with the Wi-Fi and the internet system used in the hospital. We have made our calculation for laser-based sensors for the ideal case. This work will support the need for ports for connecting with the internet. 2.3 Deco ELV, Xia Xin Yang, and ETL have proposed in their work titled Research on the Technology of LiDAR Data Processing about LiDAR. This work has used this paper to understand the use of LiDAR technology in the medical space. Block diagram to detect bed availability using LiDAR system. 3.0 Methodology 4.1 Ideal calculations for laser. 4.1.2 Energy. The voltage adapter powers up the Arduino Uno Wi-Fi. The microcontroller controls incoming and outgoing data traffic from the sensor. LiDAR sensor checks the patient availability. This work finds the distance traveled by the LiDAR sensor. If the distance traveled by laser reaches the other side of the bed, then it returns as 1. This is based on the comparison logic used in the Arduino Uno Wi-Fi. We use the binary logic for comparing with the calculated distance. The output feedback from the receiver sensor sends back this signal to the Arduino Uno Wi-Fi board and it could be displayed in the Arduino Web IDE and Arduino Uno Wi-Fi AP. It can be hosted from IP generated from serial monitored using Arduino Uno Wi-Fi AP/browser. This link could be broadcast to others for viewing across the globe. 5.0 Inference. An automatic bed tracking system using IoT is designed to handle the bed requirements during the pandemic. This will be useful in places where automatic bed tracking is necessary. This work may be used in hospitals to monitor bed availability for administration purposes.